Thank you for selecting Enverus Subsurface Studio, ESS, the industry's leading-edge analytical interpretation and modeling solution. Enverus Subsurface Studio is designed to seamlessly integrate geological, geophysical, and engineering data for subsurface analysis with a single enterprise environment, offering the ideal multi-user experience through shared projects, direct data access, and integrated workflows. This quick start guide serves to educate new users on the fundamentals of project creation, data import and management, and primary workflow functionality. Each section includes a set of video links offering related context and guidance along with helpful tips to maximize your productivity. Need further assistance? Please contact the Enverus Sub Studio support team with some information here. Within this Quick Start Guide video series, we'll go through the following table of contents. You can also search for individual videos of the below table of contents in the Launcher Videos tab. Enverus Quick Start Guide video series, Section 1, Getting Started with Enverus Subsurface Studio. Enverus Subsurface Studio is installed and configured by your organization's IT department following a specific set of protocols to ensure data integrity and security. Before accessing Enverus Subsurface Studio, please consult with your management team and IT administrators to verify your permissions and login credentials. Start Enverus Subsurface Studio ESS from its desktop icon to open the primary launcher interface. Here you will find a dashboard that lists project and session information, a video section that provides educational training videos, and a content section that offers the latest ESS news updates, usage tips, release notes, and this quick start guide. An additional set of icons in the upper right corner provides access to settings, data management, account information, and user help. The launcher interface is designed to be both functional and intuitive. Take a few moments to explore its menus and options, which are detailed below. All ESS projects are accessible from the dashboard, which is composed of two sections: a project panel where users may select an active project and view the number of connected users and sessions, and a sessions panel that lists all saved sessions that are linked to the active project. In ESS, an individual project may consist of any amount of data sourced from any location on Earth, not limited by size, survey, region, or projection system. A session is a file that links to a specific project and preserves the user's saved work in workspaces. When working in ESS, most users will only ever need to select an active project, highlight a corresponding session, and click Launch Subsurface Studio in the primary launcher interface. In some cases, a user may wish to create a new session to link to an active project, either because no sessions currently exist or an additional session is desired. Click New in the Sessions panel, supply the session name and unit system. Click Create New Session. Pending access verifications, ESS will prompt the user to choose whether to load data for the active project database into the new session. Selecting No will open the new session as a blank state. In either case, once a session has been opened, pre-existing project data may be added at any time via the File menu option, Data, Add Data to New Session, or its corresponding icon in the upper left corner of the ESS primary user interface. These options provide users with flexibility to minimize loading times and prevent hampering their sessions with unnecessary data. It's a good practice to periodically save sessions when working in ESS, either via File, Save Session As, or the Save Session icon in the upper left. Doing so preserves the user's workspace layout and more. Be sure to catch the next section in the Quick Start Guide series, Section 2, covering Project Administration. Enverus Subsurface Studio Quick Start Guide video series, Section 2, Project Administration. ESS projects are created and managed by users with administrative privileges. This Project Administration Quick Start Guide video series will cover these 6 items here. Install MariaDB Server. ESS is built on the MariaDB server, the leading open source database that ensures speed, reliability, and versatility. Project administrators should first download and install the latest version of MariaDB server from https://mariadb.org/download in accordance with their IT protocols. Refer to the ESS setup guide for details. Configure Enverus Subsurface Studio. Download the latest version of ESS from the Enverus gallery and run the executable to open the ESS launcher. The setup usually goes by pretty quick. Then open the executable once the setup is run. Note that the Enverus credentials may be required for validation. First-time users will be given the option to configure and save their system preferences. The default settings should function in most user environments, but may be modified at any time in accordance with IT protocols. Initialize a project database. If ESS has not been configured to connect to a MariaDB database, the ESS launcher will prompt the user to do so. Follow the on-screen menus to provide administrative credentials, assign a host name and port number, test the MariaDB connection, and create a project database. If a prior MySQL installation exists, the administrator may need to change the default 3306 port number during this configuration. Create an ESS project. If no ESS projects have been created, the ESS Launcher will provide the option to do so. The Create Project tool requires assignments for the project's name and description, database connection, file storage location, datum values, and coordinate reference system. Coordinate systems may be filtered by EPSG code or regional name, and creating the project will validate all assignments and auto-register standard users. Transfer legacy projects. ESS provides the option to transfer legacy transform projects from MySQL, Postgres, SQL, or Oracle databases. Access the databases icon from the upper right corner of the ESS launcher and select the option to transfer legacy transform project. Here, administrators can connect to legacy projects, assign destinations, manage auxiliary directories, and transfer projects within a single practical interface. Explore additional tools. The ESS launcher provides convenient access to many other tools and settings for project management. Administrators have options to update release versions, assign user access permissions, publish projects at team or company levels, designate additional administrators, configure cloud-based services, assign local database restrictions, and more. The settings or preferences marked with a question icon even offer additional tooltip support. Explore this versatility to optimize ESS within your organization. Be sure to catch the next section in the Quick Start Guide series, Section 3, covering importing data, external data files. Enverus Quick Start Guide video series, Section 3, importing data, external data files. All external data file importers are accessible from the Data Import menu option in the upper left corner of ESS. While ESS supports many common standard and bulk formats like SegWi for seismic, Alias for well logs, and OWX for well data, most data types are easily imported as standard ASCII or Excel files. Each import wizard is generally self-guiding and will prompt the user for any information that must be assigned to column headers or data fields. Note yellow cells before proceeding to the next step. To facilitate the process, we suggest the following import file formats in the order of import. Let's start with well locations. ASCII or Excel spreadsheets with columns for a 14-digit API, well name may be separated into two columns of prefix and suffix, X coordinate longitude, Y coordinate latitude, elevation, typically KB or GL, and well TD. Headers such as operator, county, field, etc. may be assigned in additional columns and are recommended when available. Note, the columns in the import file do not need to be ordered by or limited to the headers listed here. Only these 6 columns are required for importing. Well paths. ASCII or Excel spreadsheet with columns for 14-digit well API, MD, azimuth, and inclination. Additional header combinations are supported by the importer if preferred. Note, for new users, we strongly recommend using the well paths legacy importer for simplicity. Well data LAS. Alias 2.0 files may be imported in bulk. ESS will attempt to match all incoming well APIs from the imported LAS files to the corresponding wells defined by the well locations importer. Note, for new users, we strongly recommend using the non-legacy well data LAS importer for simplicity. Well tops. ASCII or Excel spreadsheet with columns for 14-digit well API, well top name, well top MD. We also recommend using the row formatted version of the well tops importer when prompted. Well scalar attributes. Use the import scalar and/or production values for individual wells. ASCII or Excel spreadsheet with columns for 14-digit API, scalar attributes. Each attribute must be assigned a corresponding property type and unit. Use the Create Attribute menu option to define the attribute name and property type. You'll just do a right-click in that column header for that. Then assign the header and finally click the designated header to assign the unit. Horizon surfaces. ASCII or Excel spreadsheet with columns for inline, crossline, x-coordinate, y-coordinate, and z-coordinate. Positive is going to be depth in this case, and negative is going to be elevation. Attributes associated with an imported horizon may be contained in additional columns and assigned appropriate headers, property types, and units during the same import. Culture data. Standard file formats are supported like .shp, .dxf, .asc, and .pha are supported. Seismic data. Standard 2D and 3D SegWi formats are supported. ESS importing external data quick tips. The selected rule profile pull-down options are at the bottom of the main importer screen in the lower left. They define behavior when importing data that may already exist in the project. In addition, assign Share Coordinate System pull-down options where required. Choose Session Coordinate System if incoming data matches the project CRS, or press Create New Coordinate System if incoming data are in a different CRS. ESS will automatically transform any incoming CRS data to the default project CRS. Be sure to catch the next section in the Quick Start Guide series, Section 4, covering importing data, Enverus Data Link. Enverus Subsurface Studio Quick Start Guide video series, Section 4, Importing Data with the Enverus Data Link. Enverus Subsurface Studio introduces the Enverus Data Link, a powerful new data connector that provides direct access to the Enverus well database. The Enverus Data Link gives ESS users the option to import well data into their ESS projects through a few simple clicks, bypassing the process of downloading Enverus data from the web and importing manually. A robust and flexible design allows users to easily ingest new well data, enrich existing data, and update Enverus data within an ESS project. Launch the Enverus Data Link via Data, Enverus Data Link, or its corresponding icon in the main icon row. A new workflow panel opens with a list of import options for wells, wellbores, tops, logs, and associated data types. Highlighting an import option will provide a description of that workflow along with symbols like a green check to indicate whether the required session data are present, or a red X to indicate that the required session data are not present. The Enverus Data Link offers ESS users the flexibility of building their projects from scratch or enriching their existing proprietary or third-party well information with Enverus Source Intelligence. In each case, every data element sourced through the Enverus Data Link carries the Enverus interpreter flag, allowing users to easily differentiate Enverus source data from proprietary or third-party data. All import workflows are self-guiding and comprise one of the following sections: a sources panel where input data are selected, a settings panel while data filters are applied, and a results panel where imports are committed. Note that the sources panel may contain separate tabs for designating well or wellbore import elements as appropriate. When selecting import elements, users may check items individually or utilize the right-click menu options to select or deselect any combination of entries from one or more tabs. Queried items in the settings panel may be filtered in a similar manner. Note the green plus and minus icons for selecting or deselecting all items in the list. Once all desired items have been selected, clicking the Commit button will add those selections to the results panel. Note that the selections may be committed only once per execution. The Commit button becomes inactive once clicked. If any items are committed or excluded by mistake, simply highlight the current entry and click the Delete Selected Results icon, which is the red X, to remove it from the results panel. Clicking Apply will execute the data import as a background process, allowing users to continue their work in ESS while the operation proceeds. Upon completion, ESS will present a summary of results, which may be saved as a well or wellbore list, viewed in a 3D scene, or exported to a CSV file. Note in the data tree that the data element sourced through the Enverus Data Link carries the Enverus interpreter flag. Here, it is helpful to clarify the ESS distinction between wells and wellbores and related well list and wellbore list as import elements. A well is defined by a unique well identifier, typically 12 or 14-digit API, the well name, surface location, elevation, and optional well headers such as operator, county, status, etc. A wellbore consists of survey information, typically MD, inclination, azimuth, or DX and DY, that is assigned to a well to define its spatial trajectory. When importing elements through the Enverus Data Link, users often will find that equivalent selections are available in both the wells and wellbore tabs. Elements such as tops, zones, and logs are attached to the wellbore. Users may select import elements from either or both tabs to maximize their data queries. Here is some Enverus Data Link quick tips. Be sure to catch the next section in the Quick Start Guide series, Section 5, covering the user interface and Basemap basics. Enverus Subsurface Studio Quick Start Guide video series, Section 5, User Interface and Basemap. The default Enverus Subsurface Studio session comprises 3 primary sections: the file menu at the top, the data tree on the left, and the workspace on the right. The data tree and workspace are separated by a movable vertical sash. The ESS file menu system is designed for simplicity and user accessibility. Workflows are grouped by discipline: geology, geophysics, engineering, microseismic, MV stats, and data operations: file, data, display, preferences, and help, to provide context for the selected activity. In most cases, launching a workflow or data operation from a file menu will open a corresponding panel in the workspace. These panels often include their own contextual icons to access additional functionality specific to that workflow or operation. The data tree consists of Data Panel and Views Panel. The Data Panel serves as an access point for all data contained within the current project. Data types are typically automatically categorized, and most can be expanded to reveal lower-level contents. Highlighting an entry in the Data Panel will display its individual components in a separate list below, which can be further filtered via pull-down options and search bars. The Views panel retains all displays that have been opened in the workspace. From here, users may recall any display that was previously closed via the X in its title tab to continue their work. The workspace stores all active workflows and display panels in the current session. New workflows typically are launched via the file menu options listed across the top, while new display panels are opened via the Add New View pull-down menu situated within the main icon row. All new ESS sessions include a default home basemap display in the workspace. To add data to the basemap, click on the small expand panel icon, the blue arrow at the top of the basemap layer manager. In the upper left corner, this will open the layer manager where the data layers may be added via the leftmost blue plus icon, Add Layer to Basemap. The user may choose from over 25 types of supported data layers, including web map features, ArcGIS services, and a variety of imported data types, many of which offer configurable display options once selected. Once added, data layers appear sequentially in the Layer Manager. Here, layers may be checked on or off for display, reordered. You highlight a layer and then use the blue up and down arrow icons to move. Toggle to show or hide legends, and you can even adjust for opacity. Right-click on any active layer in the Layer Manager to access the Style menu for further customization and to perform additional options. To manipulate the basemap, simply left-click and drag to pan and scroll the mouse wheel to zoom. Zoom sensitivity may be adjusted in the Basemap Settings configuration panel from the File menu, Preferences, and the Preferences icon. Any panel in ESS may be relocated by left-clicking and dragging its title tab. For example, a user may view 2 display panels simultaneously by dragging one of the tabs towards the edge of the main ESS window to split the workspace. Panels may also be maximized and reset by double-clicking their respective tabs. Take care of moving panels to avoid missteps. In many ESS displays, typing Ctrl-Shift-M will open a small window with contextual hotkey functionality for the active workflow. Note this shortcut for reference while mapping, creating transects, or picking tops as described in the following sections. The Layer Manager covering some items in your view, click the tack to unpin. Explore. Right-click on everything. ESS is full of contextual right-click menu options for display customization, workflow operations, and data management. Be sure to catch the next section in the Quick Start Guide series, Section 6, covering the 2D mapping utility. Enverus Subsurface Studio Quick Start Guide video series, Section 6, 2D mapping utility. The ESS 2D mapping utility is built into the basemap. It may be accessed via the Launch Mapping Workflow icon located in the upper right corner. The mapping utility comprises three configuration panels: input data, algorithms, and grid tabs. The bottom of the mapping utility also provides global options for toggling source points on, trimming data by regions, enabling live updates, and applying or saving changes. The input data panel is where the user assigns the data types to be mapped. Select an option from the pull-down menu and click Add to create a new tabbed panel of that data type. Each data type panel contains sections for relevant input parameters. Using well tops as an example, there's a source field to specify the source mapping data, a data range filter section to limit the range of the source mapping data, and a wells section that lists the individual wells contributing to the mapped result. Users may further limit contributing wells using the pull-down well list filter option and/or by checking individual wells on or off. Once all input parameters are specified, it's useful to check the live box at the bottom of the mapping utility to display the mapping result in the Basemap. In the Basemap Layer Manager, this result will be listed as temporary mapping result and can be styled appropriately with a right click. While the live box remains checked, any changes made to the mapping utility will automatically update the temporary mapping result. The Algorithms panel allows the user to select the type of mapping workflow to be performed. While the default interpolation workflow is the most common, advanced methods such as co-kriging, sequential Gaussian, and error mapping removal may be selected and parameterized accordingly. Basic interpolation schemes offer a choice of algorithms including Simpson, B-spline, and minimum curvature. Experiment with the different parameter combinations to view the live updates in the Basemap and refine results as needed. The grid panel allows the user to assign a spatial geometry to the mapped result. By default, an automatic grid is computed to contain all the source points. The Select Grid option allows the user to assign a predefined geometry based upon an existing horizon surface, seismic bin grid, or user-defined grid. To create a grid manually, activate the Create Aerial 2D Mode icon in the upper left corner of the Basemap. Use Control Left Drag to draw the new grid on the Basemap. Then adjust its position and dimensions via the corresponding Aerial Grid Parameters panel that appears on the right, or by clicking and dragging the grid's control points in the Basemap itself. To save the manual grid, double-click elsewhere on the Basemap to supply a name and click OK. It is now available for selection in the list of predefined grids. Note, the pull-down bar is used to assign a grid resolution. 1 in 10 offers 10 times higher resolution with a defined space, while 10 to 1 is 10 times lower. Once all the temporary mapping modifications have been finalized, save the mapped result by clicking Create at the bottom of the mapping utility. If saving the mapped result as a horizon surface, use the pull-down bar to associate the result to a geological feature or create a new one if needed. To display a mapped result at a higher pixel resolution in the Basemap, access its Style menu and change the interpolation method from nearest neighbor to bilinear. You can do that with the right-click Style. To reopen a saved map result from the data tree, you can also right-click on that surface horizon and select the mapping option. To go find that in the data tree, you'll go to Geological Feature Data, Geological Features, and then Horizon Surfaces. And then that right-click option. Be sure to catch the next section in the Quick Start Guide series, Section 7, covering well log templates, well transects, and well cross-sections. Enverus Subsurface Studio Quick Start Guide Series, Section 7, Well Log Templates, Well Transects, and Well Cross-Sections. One of the most common conventional workflows in ESS is generating a well cross-section from a transect on the Basemap. This can be done in 3 basic steps: creating a well log template, defining the well transect on a Basemap, and launching a cross-section. Creating a new well log template via the File menu option Display Log Template Editor. Use the selection fields on the left to filter the wells by well list or well bore, and to also list available wells by type. To add a well log to the template, highlight a log in the list and click the blue arrow icon. By default, a new track is created each time a new log is added. However, multiple logs may be added to a single track by first clicking on the desired track to highlight it and then adding that selected log. Note the right-click options available from the well tracks, where users may add delete tracks, adjust log properties, and enable disable drag-drop functionality to reorder the well track sequence. Icon options to save a template, create a new template, and load a saved template are located in the upper left corner of the workflow panel. The ESS Basemap supports well-to-well and projected transect modes. launched via their respective icons near the upper left corner of the base map. To define a transect, start by clicking the icon for either a well-to-well transect or a projected transect. A well-to-well transect is created by clicking directly on well locations on the base map and remain essentially static once created, but allows for wells to be added or removed. After the final well is selected for inclusion, double-click elsewhere on the base map to supply an output name. Then click OK to save. A projected transect may be created by clicking anywhere on the base map to assign inflection points. Note the control panel that opens to the right of the base map when this transect mode is initiated. After the final point is assigned, double-click elsewhere to release the rubber band and view the result. The projected transect is surrounded by a visible swath that highlights all wells currently projected to it. In the control panel, the user can adjust the parameters for distance, angle, and method of projection while viewing updates on the base map. Once the desired settings have been applied, click Commit Transect in the control panel to save it. After saving either a well-to-well or a projected transect, ESS reverts to its default selection mode, and the resulting transect is now displayed in bold on the base map. Note that all transects are contained within a single Transects Transverses layer in the Basemap's Layer Manager, accessed via the Expand panel icon in the upper left corner, allowing each to be toggled on and off via the layer's right-click Style menu. In addition, users can see the saved well-to-well or projected transects in the data tree. To launch a well cross-section from a transect on the base map, first select the desired transect by clicking on it. Then right-click and choose Correlation View. Select a predefined well log template from the available options and click OK. The cross-section will open in a new tab panel. Recall from Section 5 that any panel may be repositioned by dragging its title tab. In the new correlation view, note the icons above the display that allow for annotation, ghosting, resizing, zooming, changing well log templates, and more. The Edit View Settings icon in the upper right, the blue wheel, allow the user to customize display features for any data currently shown in the correlation view. As with other displays, new data may be added to the correlation view via the Layer Manager, accessed from the Expand Panel icon, the blue arrow in the upper left corner. Note that ESS supports multiple correlation views at any time from any number of selected transects. And don't forget, type Ctrl-Shift-M to access the hotkey functionality. Be sure to catch the next section in the Quick Start Guide series, Section 8, covering well log interpretation and auto tops picking. Enverus Subsurface Studio Quick Start Guide video series, Section 8, Well Log Interpretation and Auto Tops Picking. To initiate tops picking in a correlation view, first click the correlation picker icon near the upper left corner of the display. This enables the top correlation mode, and a new set of icons will appear near the upper right. Next, click the Select button to open the top selection window. Here, users may choose any number of available well tops to interpret and/or create a new well top to add to the list of selected options. Simply highlight any available well tops in the list on the left, then click the blue arrow icon to add them to the selected list on the right and click OK. All selected tops are now available to interpret while in tops correlation mode. And the active top may be selected from the pull-down arrow portion of the Select button. To manually interpret a well top, simply left-click on any log track to place it. Additional picking options may be referenced by clicking Ctrl-Shift-M to open the hotkey window. The user may exit top correlation mode at any time by clicking the default cursor mode icon. Saving the transline session via File, Save Session As will preserve all interpreted tops. Here, it is helpful to understand that ESS offers interactive functionality between its base maps and cross-sections in the correlation view, a resourceful QC tool, especially for the well top correlation and mapping. To illustrate this, first adjust your display so that one panel contains a base map with a projected transect, and an adjacent panel contains the well cross-section in your correlation view launched from that transect. Next, left-click anywhere on the projected transect to highlight it, then right-click and choose the Edit Projected Transect option to open the control panel. Here it's important to ensure that the Auto Commit option is checked, and then in this edit mode, hovering the cursor over the projected transect will show a pink dot. Now left-click on the projected transect and drag it to a new position on the base map. Note that the well logs displayed in the cross-section will automatically update to reflect the newly projected wells. As we will see, this dynamic interaction further extends to the ESS mapping functionality, which can be used for the QC of auto pick tops in the cross-section. ESS harnesses the power of the computer to employ an advanced auto top picking algorithm, allowing hundreds or even thousands of well tops to be interpreted automatically within seconds. To take advantage of this automation, first place a few manual picks on any wells in a cross-section, then Control-Shift left-click anywhere in the cross-section tracks to initiate the auto picker. The ESS auto picker will attempt to pick the same geological event on additional wells in the correlation view cross-section following a set of user-defined parameters accessed via the auto top picking parameters icons above the cross-section display. When completed, a dialog in the lower right will show the results of the auto tops tool. Plus, you can always do Control-Shift-M to remind you of those mouse bindings. Users retain the options of overriding any auto picks by repicking them manually or removing the auto picked results entirely by clicking the undo yellow arrow icon in the main icon row. If the user is satisfied with the remaining auto picks, be sure to save that session. To take full advantage of ESS workflow interactivity, consider using the mapping utility to live grid the well tops currently being interpreted in the correlation view. Following the procedures previously mentioned, the user may continue to reposition the projected transect on the base map, create new manual or auto picks in the updated wells in the correlation view, and then QC the live gridded result. To push the envelope even further, consider switching to the Basemap Auto Top Correlation mode via its icon above the cross-section display in the correlation view. In this mode, the user can select from a new set of icons to define a region on the base map that contains previously picked tops. Therefore, the Auto Tops picker will attempt to pick all wells that fall within the defined area rather than the projected swath. Now you're playing with power. Be sure to catch the next section in the Quick Start Guide series, Section 9, covering well lists, alias managers, and data generation. Enverus Subsurface Studio Quick Start Guide video series, Section 9, Well List, Alias Managers, and Data Generation. Virtually every ESS workflow that utilizes well data allows for the input selection of a well list, a subset of project wells defined by the user. Access this tool via Data, Wells, Create Well List. To open a new workspace panel divided into two parts, an upper section with various filter options and a lower section listing all wells that are passing the current filter or filters. By default, all wells in the lower panel are checked on, meaning all are passing, so no filters have been applied. And the number of passing wells is noted at the right side of the display. The user may select from various filter categories to apply, and some filter options allow the user to specify data range limits, and any number of filter options may be applied from any category. Note that each category tab shows the number of filter options currently selected, with a little green circle check. Also note that the most filter categories include sub-options to specify whether any or all selected filters are presently applied, like in well tops or well logs. Once all desired filters have been designated, click the Apply Filters button in the middle of the display to view the passing wells below. To save a well list, enter an output name in the yellow cell and choose whether to override an existing well list or create a new one. Click OK. The saved well list is now available in the data tree for selection in relevant workflows. ESS provides alias managers to preferentially group well velocities, well logs, and well tops for bulk access in multiple workflows. Accessed from data aliasing, each manager allows the user to select from a list of unique names or mnemonics to include in a corresponding alias. Simply highlight the desired names or mnemonics in the left panel and either drag them into the right panel or click the Create Alias icon at the top. Aliases can also be created with just a right click. Aliases can be expanded to show their constituent elements, and these can be reordered via drag drop. When referencing aliases, ESS always applies their components in the order specified here, so that the uppermost entry in the list takes priority. Note that the ESS Top Manager requires well tops to be aliased to a specific geological feature or horizon to ensure consistency when referencing geological events. When creating aliases, be sure to access additional right-click options to copy, remove, delete, and even reassign default aliases as desired. Another added bonus in the Tops Alias Manager is you can update the color of a top or the well top alias here. In many respects, the Data Generation Wizard comprises the most powerful set of workflows offered within ESS. Access these tools via Data, Generate New Data, or from the corresponding icon in the main icon row.
Primarily, these options are designed to consolidate multi-source data to the well domain for subsequent correlation and analysis. Examples may include extracting a representative scalar value from a gamma ray log to a production interval, or generating a pseudo log along a wellbore from a mapped geological attribute or 3D seismic dataset. The wizard offers additional workflows for creating well zones from tops, calculating net thicknesses from indicator logs, merging seismic volumes, and more. Workflows are categorized for easy reference, and selecting a workflow provides a detailed description of the operation along with the symbols to indicate whether the required data inputs exist in the current project. All data generation workflows are self-guiding and generally consist of 3 primary sections: a sources panel where the input data are selected, a settings panel where extraction and sampling options are specified, and a results panel where outputs are added for processing. Multiple combinations of sources and settings may be added to the results panel for bulk data generation, and output file names and descriptions may be edited accordingly. You'll see a pencil in the lower panel in the results panel to do that. Once all desired extractions have been finalized, clicking Apply will execute the operations and generate a summary of the results. In most cases, icon options will allow the user to export these results to a CSV file and/or save them to a well or wellbore list for further analysis. Saving the ESS session will permanently write all outputs to the project database, where they can be rendered for 2D, 3D visualization and interpretation. Correlated in charts and crossplots, sourced for various data calculators, and utilize in ESS's powerful multivariate statistical analysis MVStats workflows. Be sure to catch the next section in the Quick Start Guide series, Section 10, covering data analysis and calculators.
Enverus Subsurface Studio Quick Start Guide video series, Section 10, Data Analysis and Calculators. ESS offers a robust set of data analysis tools to correlate and analyze attributes derived from wells, logs, horizons, seismic, and other sources. These may be accessed via the MVStats file menu, where the user will find a list of analysis options categorized by data type. This guide references the well data analysis option. The data analysis panel consists of 3 primary sections: the attributes list on the left with data filter options, a primary correlation and plotting space in the center, and a set of statistical and customization tools on the right. Note the icons in the upper left corner of the attributes list that allow the user to select data providers and sources. These are useful to show or hide additional attributes available in the project and to limit input data by a predefined well list. To create an analysis, first select the desired type using the Add New Plot pull-down menu in the upper right corner of the workspace. This opens a panel where the desired attributes can be plotted either by dragging them from the attributes list on the left or using the Axis Data Selection arrows when available. Take advantage of right-click options in all types of plots in these different views. Show marginal histograms and plot axes, and adjust display parameters as well. Additional panels in the right allow users to fit regression lines, apply filters, and customize data points by color, size, and shape. To create an analysis, first select the desired type using the Add New Plot pull-down menu in the upper right corner of the workspace. This will open a corresponding panel where the desired attributes can be plotted, either by dragging them from the attributes list or by using the Axis data selections. We suggest using the new correlation table to kind of facilitate data correlations in the XY space. Once here, users can populate a data matrix consisting of any number of attributes and then immediately get that linear correlation between them. Just double-click on any cell and the matrix will open a separate cross-plot for the corresponding attribute pair. And here I go with the right-click options again, so you can update the data and display in that plot. For advanced analysis, users may switch to MVStats workflow panel to apply ESS's multivariate analysis algorithms for data classification and regression. These advanced workflows are detailed in ESS's user guides and training videos. Users may access ESS's data calculators via data calculators to apply various mathematical and scientific expressions to well zone attributes, well logs, seismic data, horizons, and other types of data. As an example, the ESS well log calculator consists of three primary sections: a script panel for entering equations on the left, mnemonics and wellbore panels used to populate equations and filter outputs in the center, and a results panel to QC created logs on the right. Begin a calculation by populating the script panel with a logical equation. ESS includes many predefined examples pertaining to petrophysics, rock physics, net pay indicators, and more. Click on the open folder icon to view the equation library, noting each equation's full description in the lower panel when highlighted. Select an example and click OK to add it to the script panel. Next, ensure that the required input variables are assigned to execute the script. These variables are accessed from the mnemonics list in the center section. When a script is first added, ESS does attempt to auto-assign these variables by default. However, the user may reassign any variable by first highlighting that red variable in the script, then double-clicking on the desired mnemonic in the center section to overwrite. Note that a properly coded script will use bold red and green text to highlight the required variables and their respective assignments. If these colors are not visible, the script will not execute until corrected. Finally, highlight any well in the wellbore panel to preview the output logs based on the current script. Any script modifications will update the preview accordingly, allowing the user to QC results before they're generated. When all results are satisfactory, enter an output mnemonic, select the desired wells, and click Create Logs to save the new logs to the project database. If working with a large inventory of well logs, we recommend first using the ESS Well Log Alias Manager to alias any desired mnemonics. You can see Section 9 in the Quick Start Guide series for that. Then selecting the Alias radio button in the calculator before proceeding to populate the script panel. Be sure to catch the next section in the Quick Start Guide series, Appendix 1, covering advanced workflows. Enverus Subsurface Studio, Quick Start Guide video series, Appendix 1, Advanced Workflows. Enverus Subsurface Studio offers a multitude of advanced workflows in geology, geophysics, engineering, microseismic interpretation, and multivariate analysis, or MVSTATs. Detailed walkthroughs are provided via ESS's user guides and online training videos in the launcher. Within the launcher, click on the Videos tab. Use the search bar in the upper right to find a desired video. Most of the advanced workflows can be found in the user interface drop-down menus. Geology workflows, well targeting, advanced property estimator, well log normalization, raster log digitization and registration, fault modeling, and structural modeling. Geophysics workflows, seismic attributes, synthetics and wavelets workflows, seismic waveform classification, mistie analysis, velocity modeling, and more. Engineering workflows, well spacing, well interference, decline curve analysis, wellbore planning, microseismic interpretation, data visualization, treatment correlation, event analysis, and MVSTATs. Things like classification, unsupervised and supervised, hierarchical classification, plus nonlinear and linear regression, and random forest modeling. Be sure to catch the next section in the Quick Start Guide series, Appendix 2, covering quick tips for beginners. Enverus Subsurface Studio Quick Start Guide video series, Appendix 2, Quick Tips for Beginners. Maximize your productivity in Enverus Subsurface Studio by taking advantage of these commonly used workflow options. View Edit Properties of a well. From the data tree, highlight the Wells category, then right-click on a well in the lower panel and select View Edit Well Properties. From the Basemap, click on a well symbol to highlight, then right-click and select View Edit Well Properties. From the File menu, go to Data, Wells, find a well. Note that the View Edit Well Properties panel contains a listener icon in the upper right corner. When activated, the panel will automatically update the displayed properties of any selected well. Locate a well on a basemap. Click on the listener icon in the upper right corner of a basemap, then highlight the wells category in the data tree and select a well in the lower panel to jump to its location. Note that this feature can be used in combination with the View Edit Well Properties listening functionality described previously. Assign well symbols on a base map. From the File menu, go to Display Assign Well Symbols. Note that the well symbols are matched to the well status header assigned during well imports. Assign a symbol to a corresponding well status by highlighting both entries and clicking the blue arrow to match them. Once all matches have been assigned, clicking Apply will update the well symbols on the base map. Right-clicking on a well symbol in the base map and selecting Style will reveal additional customization options. Measure a distance on a base map. Click the measurement mode icon in the icon row at the upper left corner of the base map. Then click and drag anywhere on the base map to draw a distance line. Filter wells displayed on a base map. Click the Launch Well Filter icon in the icon row at the upper right corner of the base map to filter displayed wells by well list and/or attribute. Note the additional icon options that allow filtered wells to be saved to a well or wellbore list. Create a well list from a region on a base map. From a user-defined region on a base map with well locations displayed, click the Create Region Mode icon in the icon row at the upper left corner of the base map, and then left-click on the base map to add polygon nodes to encompass the desired wells. Selected wells will turn red, and then right-click and select either Create Well List or Send Selected Wells to Create a Well List view for additional filtering options. From a region defined by a culture layer, click the Create Region Mode icon, then Add Map Polygons to Region icon. Left-click inside the culture polygon to select the wells within, then right-click and select Create Well List or Send Selected Wells to Create Well List View for additional filtering options. Create and assign a well annotation template. To create a template from the File menu, go to Display, Create Well Annotation Template. Drag and drop the annotations from the tab panels on the left to the desired positions on the right. Right-click on Assign Annotations to change colors or delete. To assign a template, from the Layer Manager in the base map, right-click on a displayed well list and select Style. Annotation templates may be assigned and customized from the Annotation tab. Alternatively, right-click on an individual well on a base map to access its Style menu. Display a well in a correlation view without a transect. Right-click on any well in the data tree or on a base map and select New Correlation View. ESS will prompt the user to select wellbores, log template, projection metrics, and depth calibration. Filter session data by user. Click on the Assign Interpreter Filters icon in the main icon row. Highlight the desired interpreters and use the blue arrow icons to move them between the available and assigned list. Data will be hidden from any interpreters who are not assigned to the current session. Save and load viewer template files. Basemap, correlation views, section views, and 3D scenes can be saved and restored as templates to facilitate the recreation of new display panels. To save a template, click on the Save Template File icon in the upper right. To load a saved template, access the Add New View pull-down menu in the main icon row and select Open Manage View Templates. Change the background color of a display. Change the background color of a basemap or 3D scene by accessing Preferences from the File menu. Highlighting 3D Views configuration and basemap preferences in the left panel will reveal style options. Note the additional configuration settings in this menu for user customization. Share and track cursors between views. Click on the Share and Track Cursors Between Views icon in the icon row in the upper right corner of the respective display. For example, enabling this icon in both a basemap and a well correlation view will allow cursor tracking along the corresponding well transect. Change default colors of horizons and well tops. From the File menu, go to Data, Aliasing, Top Alias Manager. Default colors may be changed by clicking on the respective geological feature, alias, or top color swatches. Note the entries may need to be expanded to access and assign individual top colors. Access project information. From the File menu, go to File, Session Properties to access information about the current project, coordinate reference system, data assignments, and more. You're off, friends. Enjoy using Enverus Subsurface Studio.